Hello everyone. Today we are going to talk about limits and their properties. First, let me talk about our objectives. First, we need to estimate a limit using a numerical or graphical approach. Second, we need to learn different ways that a limit can fail to exist. Third, we need to learn how to write a limit. Now, let me talk about the limit. The limit is the value of f(x) as x approaches a certain number. So, a limit is written as limit as x approaches c of f(x) equals to L, where lim is the abbreviation of the word limit. X to c means that value of f(x) is approaching the number c. f(x) is a function, and L is a constant number and the value of limit. So the limit is read as the limit as x approaches c of f(x) equals L, or the limit of f(x) as x approaches c of f(x) equals 1 L. Now we have an example to find the limit of a function numerically. Now let me find the limit as x approaches 1 of x cubed minus 1 over x minus 1. So let me find some values. X approaches 1 from the left, and f(x) approach 1 from the right. So we get a table. The x value are 0.75, 0.9, 0.99, and 0.1999, and 1.001, 1.01, 1.1, and 1.25. So we put these x values into these functions, so we get the value of f(x). So in this table we can when x approaches to the 1 from the both sides, the f(x) is more close to the 3. So the answer of limit as x approaches 1 of x cubed minus 1 over x minus 1 equal to 3. Now this is the graphically function. So the answer is still 3. So here is an example. Graph and find the limit as x approaches 0 of the function f(x) equal to x over x plus 1 square root square minus 1. So here is a table. In this table we can find the f(x) is more close to the 2, so the answer is 2. Observation about the limit. Even though f of 0 is undefined, the limit equals 2 because both sides approach 2. So in general, the limit exists for a function if the left and the right limits approach the same number. This is regardless of whether the value of f(x) at the limit is equivalent to the limit or exists at or that point. So fx equal to 1 and x not equal to 2 and fx equal to 0, but x equal to 2. So the answer we find is limit as x approaches 2 of fx equals 1. So we find the example of limits that do not exist. The left and the right limits are different. They're showing this in this graph. So the limit as x approaches to the 0 of the absolute value of x over x is equal to do not exist. So it's unbounded behavior. So the limit as x approaches to 0 of 1 over x squared is also do not exist. Although you could specifically say it approaches positive infinity, however, the limit L has to be a constant number. In this graph, we know the limit as x approaches 0 of 1 over x cubed equal to do not exist. So it is the third example, the oscillating behavior. It jumps back and forth between positive 1 and negative 1. The limit as x approaches the 0 of sine 1 over x do not exist. So it's an exception of oscillating behavior. Each oscillation is getting smaller, closer to 0 in this graph. So
and then I want to talk about the homework page from 55 to 58. And the first question is lim x to 3 x minus 3 over the x square minus 9 is equal to what? So first we use the numerical approach to find that when x is 2.999 and fx is equal to 0.16669 and when x is equal to 3.001, the fx is equal to 0.1663. So also we cannot use the x is equal to 3 to put it in the function, but we can find that the lim x to 3 x minus 3 over the x squared minus 9 is equal to 1 over the 6. We use the numerical approach can find the solution. And next page we talk about lim x to 0 sine x over the x. So first we use the x is equal to negative 0.1. We put it in the fx. We can solve that fx is equal to 1.998 and when x is equal to 0.001, the fx equal to 0.9999, and we use the numerical approach. We can find that lim x to 0 sine x over x is equal to 1. And next question we want to get the solution of the lim x to 3 4 minus x, and we can use the graphical approach to find that lim x to 3 4 minus x is equal to 1, and lim x to 0 sec x. We also use the graphical approach to find that the lim x to 0 sec x is equal to 1. And next page, we use both of these. We use the numerical approach. Lim x to fx when 4 minus x will not equal to 1, and when x is equal to 1, and the answer is 2. So finally we can find that the lim x to fx is equal to 2. Next, lim x to 1 fx when x is not equal to 1, fx equal to x squared minus plus 3, and when x is equal to 1, fx equal to 2. So use the graphical approach, we can find that lim x to 1 fx is equal to 4. And then next, lim x to x squared and x minus 2 approach. So this value over the x minus 2 is we cannot find the answer because the left and the right limit do not match at x equal to 2. And next question, lim x to 5 2 over the x minus 5. We can also not find the answer because the left and the right limit do not match at x equal to 5. And next page, x equal to 0 cosine 1 over the x. So from the graph we can find that we cannot get the answer because the function oscillated between 1 plus and positive 1 and negative 1. And the next page, lim x to pi over 2 tan x is not. We can also not find the answer because, like the graph shows, the left and the right limits do not match at x is equal to pi over 2, and the function is unbounded. And next page is the multiple choice. It's not the multiple choice. It's the we need to find the solution of fx x is equal to 1. We use the graph. We can find the fx f1 is equal to 2. And the next question is lim x to 1 or fx. We cannot find the solution of this because the left and right x to 1 do not too much match. And the next question is f is equal to 4. F4 is we cannot find the f4 because there is a hole in the graph. And next is lim x to 4 fx. Lim x to 4 fx is equal to 2. We can use the graph to find the solutions. And next page, at f negative 2 we cannot find the definition because the asymptoted, and lim x to 2 fx we negative 2 fx we can also not find the definition because it is unbounded. And the next page, and next is f to 0. We can find the we can use graph to find that f0 is equal to 4. And next is lim x to 0 fx. We cannot find the definition. We cannot find the solution because left and the right limits do not match. The next is f2. We cannot find the solution because in the graph the when x equal to 2 is a whole. And the next lim x to fx, we can use graph to find the answer is negative 0.5. And the next f4 we can use graph to find the answer is 2. And the next lim x to 4 fx we cannot find the answer because it's unbounded. And the next page, fx when x is smaller and equal to 2, fx equal to x squared, and x is bigger than 2 but smaller than 4, fx is equal to h multiple 2x, and when x is bigger and equal to 4, fx is equal to 4. So the limit exists for value except x equal to 4. And the next page, the definition if lim on page 52 requires that fx is a function defined on open interval containing c, except possibly hc. Why is this requirement necessary? Because a function can be undefined hc but still have a limit. And this is still of a true or false question. So if f is undefined at x equal to 3, then the limit of fx as x approaches c does not exist. It is false because we can find the limit of fx as x approaches c. And if the limit of fx as x approaches c is 0, then there must exist a number k such that fk is smaller than 0.01 is true. If fc is equal to L, then lim x to c fx is equal to L. This is false because it's not make sure that if fc is L, because if xd is if lim x we can find any point in fc that which is different with lim x to c fx is L. And lim x to, if lim x to c fx is equal to L, then fc is equal to L, like the last question that it is also false. And this is all of our presentation. Thanks.